let you folks know what's going on with the cart. So thank you very much, Steve. Go ahead.
Thank you, Dave, for that announcement. Okay, without further ado, I'm going to introduce tonight's speaker who needs no introduction, but I'll introduce him anyway. I get to do that. Keith Snyder, KI6BDR, was a colleague of mine at Northrop Grumman, where I met him. He's considered a power user of the program FICO. He was Northrop Grumman's first uh, authority on that piece of software. So he's an expert in numerical modeling of antennas. And he's been working since, I'm not sure he's actually retired, but he is having a lot of fun in San Diego and even on Waikiki Beach. If you saw the announcement and looked at the YouTube video, sitting on the beach, admiring all the swimmers and boats and everything, using his drone. And he's going to talk about drones. He's going to talk about antennas for controlling drones, antennas for uncontrolling drones, which he calls drone killer antennas. Uh, Probably not part of the hobbyist work, but this could be some insight into some of his professional work. So, Keith, without further ado, the floor is yours.
Okay, good. First of all, I'd like to say thank you for having me. I've been working very hard on helping the soldier basically commit or connect with communications and mitigate drones. This is just really hot topic right now. Ukraine is like showing the way for everybody in the world how to use drones in warfare. So our company asked me to look at these things, and I did a lot of research and got about 430 slides in a PowerPoint presentation, and it just kept growing and growing. I said, hey, this would be a good talk for the ham radio club, just to see what kind of antennas are inside the drones and what kind of antennas are used to mitigate the drones. So I believe I have to click the share button. Is that correct, to share my screen? Does that work?
Yeah, turn on sharing. You should be able to share now.
Okay, entire screen.
There you go.
Let me see.
Okay, we can see it.
All right, let me maximize this PowerPoint. Or actually, maybe I'll do a couple of, just a couple of slides here, just to get us started here. One of the things I want to do is actually leave you with the idea or the feeling that you might want to enjoy flying a drone. So this is from that video that was in the announcement. But as you can see, you can get a nice view, a different point or perspective when you're up in the air. And this is a very famous banyan tree in Honolulu. And I'm down here flying, just sitting there enjoying the day. It's really fun and easy. And you can see different views further away. I fly down and see these kayaks, sailboats. I didn't know.
Keith, is your microphone loose or something? Because I hear a bunch of noise and you're sort of drifting in and out.
Okay, is this any better? Is it getting closer?
It's a little better, yes.
Yeah, okay. Sorry about that. So these are, this is the flight I took from our hotel. And you can see this building right here. I was trying to stay out of the line of sight, and I went down here and I saw something interesting, and I sort of flew around, and this building actually blocked my drone. So my drone decided to fly up about 100 meters and return to home. I caught it before it came back, but the drones are actually safe. They know where they came from, and they know that they should rise above a certain altitude so they can avoid trees and things like that in buildings. So Honolulu from the water looks pretty nice. Let's see if I can get on down. You can see the H here. This is where I am. I'm just sitting there relaxing. See a surfer here, sailboat there, another sailboat. Good thing about this one is you can see the coral. Nice red, rainbow sail on this one. So it's a very nice and fun, enjoyable hobby. you take your drone and on your vacation, and you can have a great time getting good photographs and just have some fun. So one thing I want to let you know is that the drones have extremely good quality. This particular drone I bought for $305 used almost a year and a half ago, and that was a really good deal. It's the DJI Mini 2. So that was really quite a good bargain when I bought it, $305. They were usually about 500. So one thing I think I want to show is, I guess what I need to do is go here. One second. This is an example of the color that I'm talking about.
Keith,
Sorry
can
about
you
the
speak up a
sound.
little bit? We're having a little trouble hearing you.
You're saying the audio is bad, is that right?
Yeah, the audio seems to be fading in and out and a little choppy. Do you have a different mic you could try?
Yeah, let me try headphones here. 1 second. Can you hear me now?
Yeah, can you make it a little louder? Or?
I don't know. I'm trying. This is, hold on.
This is better than it was.
Okay.
Oh, yeah, that's good.
Okay, I'm holding the mic now. Okay. So this is just an example of the color. Sorry about the sound. There's the sound is off now. Do you guys hear the sound when it's on? Yeah. Let's show you what's going on here. There. So this is an example of the kind of quality you can get from a drone. It's 4K. This is San Diego. And it's really amazing how much detail you can get. You can fly out and zoom in, see somebody in their kayak, see how they're twiddling their paddles. Yeah, it's really fun. So let me go right here. If you look in the water, you'll see some seals here swimming. They should come right around the corner and go into the cove there. So the quality of the video is really, really amazing. So that's what I wanted to show with this video. I'll go ahead and stop that. And exit this and get into my talk. All right. Let's see if I should go full screen. Oops. Okay. Not sure why this says set up professional audio in. I'll click on that. Okay. All right. So my talk starts with how does a drone work and simple antennas on this Mini 2 drone that I have. And it's really not simple, by the way. And a little bit on getting better range on your controller, a little bit about loss of signal and some of the signals of interest, drone jammers and extenders and repeaters. So this is where I used to work at this is Palmdale, where they produced a drone. It's called the Triton. That's for the Navy. And then the Air Force has the Global Hawk. But you can see this is a 110-foot wingspan, and that's my baby. So I'm petting it. This is my smaller drone. It's called the DJI Mini 2. And the good part about it is it has that 4K video camera on a gimbal, and that gimbal keeps the camera steady while it's flying. So even while you're turning and bouncing around in the wind, the camera stays still. This is how small it is when the drone, when you fold it up, it's in the palm of your hand. So like I said, it's really good for vacations. And I got a little travel kit, and you can see it's not very big. This is the drone extender, which is a Yagi-Uda that I can slip onto the controller. We'll talk a little bit about that, the battery. And this is what the drone looks like on the inside. This is with the cover off. So the first antenna that we see is the GPS antenna. And drones are actually controlled in position by getting the signal from all the GPS satellites, and then it has a location. So when you push on your joysticks, it's going to tell it which direction to go from where you are, and it also stores your home location where you take off from. So if you lose connection with your drone, it's going to fly back to that GPS location where it started from. And here's a little bit more. You can see the GPS and that kind of thing. This is a close-up of the leg of the front leg. You can see on the drone, I put orange tape on these so I know which direction the drone is flying. It's hard to see when it's a little tiny gray thing in the sky. So this tells me where forward is, and then I can use my controller joysticks and fly in the direction I want to when flying by eye. The antenna is stuck in here with a little coax. This is the bottom power button. These are the sensors for the ground. And when you get close to the ground, it knows when to turn the propellers off. There's a little slot here for your memory stick and a little door for the battery. And what's funny is, all this time and all this effort and all this money all comes down to a little tiny disc the size of your fingertip. All of those videos get stored on this thing. So my memory of choice is SanDisk Extreme, and that's pretty fun to use. Let's see, does this? There, that's better. So this is where the SanDisk goes into the drone. So the propellers obviously produce lift by slipping through the air, causing a little bit of vacuum up above. And I have here, if it wasn't for Bernoulli, we couldn't fly. So just imagine all those aircraft we have that wouldn't work if it wasn't for Bernoulli, the Bernoulli effect, basically. So when the air flows over the airfoil, its velocity increases at the top portion, but the pressure of air decreases. And I say that sucks, but that's what pulls the drone up. So I thought this was cool, so I put it in. There's these fluid analysis tools, and somebody did analysis of a drone, and the high pressure region underneath the drone looks pretty cool. And this almost looks like the FICO current vectors that we produce. And you can see the airflow, and that's in velocity and meters per second. And I'm not going to say what P is. Okay. This is the flight controller, and this is the one that is talking to the GPS and your joysticks. So if you're flying the drone and you push the left joystick, actually the right one, forward, then the signal goes and the GPS says you go in front of where you are now, basically. And the GPS will update. So one thing you may not know is that two of the rotors or the propellers will, like F1 and F2 are right here. F1 is going clockwise and F2 is going clockwise. And if all four of the propellers were going clockwise, the drone would start spinning. So the other two props spin counterclockwise, and that's how the drone stays, from spinning. It actually stays very stable. This is the way you control a drone. Left joystick is up and down, rotate left, rotate right, and the right joystick is forward and reverse, and slide left and slide right. So let me see if this works. This will be really 2 minutes if it works. Well, maybe not in the escape first. Okay, let's try this. And I'm going to use the controller and show how the joysticks are used to control the drone. First, I will move the left toggle forward, which should be up. This is how easy it is. Now I will move the left toggle backwards, which should be down. It doesn't fly away. Now I will move the left toggle to the left, which should rotate the drone to the left. It does drift when you make a move, though, sometimes. Now I'll rotate the drone to the right by pushing the toggle to the right. So that was the left hand. Now I'll use the right joystick. I'm going to push the joystick forward, and the drone should move straight ahead. Now I'll take the right joystick and pull back, and the drone should move back towards us. Now I will toggle the right joystick to the right, and the drone should move to the right. Now I'll move the right joystick to the left, and the drone should move to the left. And that's the demo. Okay. So that was 2 minutes. I timed that, so I thought it'd be good just to let you see it. Let's get back to the top. Let's see here. And so basically that's, just 4 moves on the left and 4 moves on the right. And you can do them at the same time. So you can go up and forward, or you usually push this one as like the thrust forward. So usually you just say, I'm going to go forward. And then you steer with the left hand going left or right when you're actually flying and trying to make a maneuver. Let me get back to the full screen. If I can. There we go. So this is how the drone works. Again, the left joystick, if you pull back, you move down. If you push forward, you move up. And on the left joystick, these two guys are going to get more acceleration and you'll turn to the left. And then these two will get more acceleration and you'll turn to the right. And I didn't quite know that before, so this was kind of fun to put this PowerPoint together. To move forward, it's obvious, accelerate the to rear, and to move backward, accelerate the to front, and then to go to the left, you do the right, and to the right, you do the left. So that's how it works. And here's, a little diagram of the parts of the drone. And you've got the motor, and you've got first-person view transmitter here, and all the different parts here that control, like the speed controllers. You have one on each of the 4 motors. And there is a power distribution, but this flight controller is the main guy. And there's a receiver up in the front and the transmitter. So how those work together is how we fly around, and it's a lot of fun. You can also use goggles and just not even use the controller and fly by the visuals from your drone. This is what a lot of people are doing in Ukraine, and they usually strap something underneath. Let's just say a munition. So this is where I really got started. Look at this trace here. I bought a spare set of antennas for the drone, and I had no idea that it looked like this. You can see the traces here and here, and now you can see it outlined in the PowerPoint. So this is basically a dipole with 2 separate arms, and it's fed from the back. So there's the outer jacket here. This is the insulator, and this is the center pin. So they have vias, and they go to those 2 traces. And I've modeled this in FICO. You can see how the code meshed the dielectric and the metal surfaces. And I fed with a little wire across the top, so I could get a plus and a minus. And these are the antenna patterns at 2.4 and 5.8 gigahertz. The 2.4 is well-rounded donut, much like a dipole. And then the 5.8 has a fill-in on the top. The insertion loss over the frequencies from 2 to 6 gigahertz is shown here. And you can see it's a dual band antenna. So the high frequency is the small arms, the shorter arms, and the lower frequency is the longer arms. Yeah. And so let's see what I got going here. This is the right antenna again. And this is what the antenna patterns look like at 5.8 gigahertz. And I thought this was quite unusual. I didn't know this was going to happen. The antenna pattern is a donut, but it's slanted. And I thought both antennas were the same. I thought the left and the right were the same when before I started this. And then I ordered those antennas and they came in and they aren't. And I said, well, that's kind of beneficial. You can actually look farther down with the right antenna, depending on where you are in orientation. But I don't know what DJI does. It's a Chinese company, and I don't know if they combine the patterns. But here's the near fields around the antenna. So it's facing to the left, and you can see that going forward and aft, there's symmetry. And along the diagonal, this is the left and right, you can see it is going up and down, up to the right and down to the left. And this is a plot of the antenna patterns, pretty omnidirectional. That's yaw, and this is fore and aft. And this is that roll pattern, and you can see that it's slanted, basically. Now, what surprised me was the left antenna wasn't the same. So I double my work before I put this talk together. I freaked out because I didn't have enough time, but I did it anyway. So here's the left antenna, and it's got 2 symmetric short arms and then 2 symmetric long arms. And this is the way I modeled it. And there's the antenna pattern. And it looks fairly symmetric. It's slightly different on the left and the right, but not bad. It does a bit of a nullish, dipole-ish kind of pattern. And so I went ahead and put the patterns on the drone. And basically what I did was I stored those patterns as a spherical wave expansion file and imported it into FICO. And then I used metal for the drone, which is a little bit severe because it's really plastic. But the fact that the drone is there and has the triangles, which are from the mesh when I put in the frequency, I can use physical optics. So it's a higher frequency technique. And the spherical wave expansion file just shoots out the antenna pattern and it smacks into the drone, and you get the resultant pattern. At 2.4, it's pretty much symmetric. And I will comment that this is probably the most omnidirectional pattern I've seen in my career. I have never seen almost a spherical antenna pattern. So that's pretty clever, and it's very good. The antenna hanging down underneath the motor. These are the patterns, in the polar chart. So forward, this is the azimuth pattern, omnidirectional, pretty symmetric left and right. And, actually, this is fore and aft. The front motors are higher than the rear motors. So this is fore and aft. And then looking at the camera, we're looking straight at the drone. So that's a little bit of asymmetry. So that's 2.4 gigs. And this is 5.8 gigs. This is for the left antenna. And you can see there is a little bit of ripple here. And that's because the antenna pattern is smacking onto this flat surface and bouncing. So that causes in and out of phase summations as you go around in this circle. But otherwise, the antenna pattern is very well behaved. That's the left antenna. Let's see what we got. 5.8 gigahertz, omnidirectional pattern, fore and aft, and left and right. Pretty symmetric. Let's see, this is the right antenna, 2.4. This is the one that should have a little bit of cockeyed at the high frequency. Looks like an apple, 2.4, fairly well behaved. And then this is the tilted pattern that we had in the element pattern. I also included the scattering from the opposite antenna as a piece of metal to be clear. And you can see these ripples. So the antenna's here, energy hits here and bounces back. And this is a plot of the currents on the drone. So you can see now, here's that diagonal pattern, and this is the current on the drone. This part doesn't get hit by anything. That's why it's pretty dark. It's blue, but the hot spots are right here. So this and this are actually two sources, and that's it adding in and out of phase, right? And the antenna pattern, there's the ripples here, fore and aft, and left and right, diagonal kind of pattern. I went ahead and bought one of these things here just to see if it does help my signal strength for my controller. And this was kind of fun, a little addition to the controller. This is the DJI controller with the joysticks. And you can add this to the two antennas that are in holding your cell phone. So this is kind of compressed. A couple things to say. This is a iPhone 7S, and I don't even have a chip in it. So it's I'm using it just for the display, and the controller hardwires into your phone. So this is called OcuSync, and it gives you extremely good range on your drone flights because this guy's providing all the power, and it's not like Wi-Fi on your cell phone. So I have taken my drone to a distance of 3.5 miles, and it did not have a problem with the signal strength. The problem I had with it was I had the controller telling me, you don't have enough battery to return home. I'm coming home now. So the smart controller tells you what it's going to do, and it takes over, turns the drone around, and starts coming home. So I went ahead and modeled that in FICO, two dipoles here, and then I also put in this surface and these wires that were in that that I measured and put them in to size. And you can see that the antenna pattern, the blue is without the drone extender, and it's 4.8 dB in the forward direction. And then with the drone extender, it kicks up to 10 dB. So that's a 5 dB increase in gain. So that's pretty cool, actually. I thought that was neat. This is a map from my iPhone. Shows where my home point was. Again, this is what's transferred from the controller to your drone, the GPS coordinates right here. And then I flew out here. This is a distance of 2.8 kilometers. And then I came back home, and it said, you don't have enough battery. So I'm coming home. So it did. And this is another flight separate from this one. And this is where I took off from, out here at this arrow. And this is kind of a view from when it turned around. So it's pretty far. This is the batteries that come with the DJI drone, and the gray standard is 2250 milliamp hours. And for another $80, I was able to get a 3650 milliamp hours. This is probably about 18 minutes, and this is about half an hour. So for a little extra money, it really helps you not be nervous when you've got enough gas. So just for fun, Yagi-Uda antennas. I went ahead and found, you can print them if you'd like. There was one here that I saw in the literature, and it was designed at 647 megahertz. It had these number of reflector, driver, and three. These are directors, and this is a reflector, and this is the driver. So I went ahead and scaled this to frequency, and this is the pattern at 647, and I had about 11 dBi. And all I did was just scale it, and now at 5.8 gigahertz, I've got about 11 dBi, and this is the antenna pattern. So I had fun doing that. And so again, here's the driver, reflector, director 1, 2, and 3. And all the dimensions are right here in inches. And the position. So the X position is shown. I guess it's really not that critical for me to tell you how to build this, but if you get the PowerPoint, you might want to fabricate one in your office. These are the antenna patterns again. At 5.8 gigahertz azimuth and elevation. So you can see the azimuth is broad and the elevation is narrow. So can we improve on using the drones? In other words, can we improve the drone performance and make it go farther and do other things? And I said, well, what happens if you decide to put one Yagi on each of the arms? Then you could actually have an interferometer if you wanted to. And I'm just showing you here that if you put an antenna on each of the arms, you can find, first of all, you get a higher gain if you're in the direction of the antenna. But if you use 4 of them and switch between them, the crossover is about, 4 or 5 dB, which is still pretty good signal compared to just an omnidirectional antenna. And you can use these 4 antennas for direction finding. So that was just an idea. And let's see. I think I'm going to segue now into the bad guys, or how to protect yourself from the bad guys. This is a detector. And I really like this particular design. It's a radar. So this is the other part of the talk where we go into mitigation and detection. I'm going to see if I escape. And let's see. This is Iris. One moment, please. I believe it's this one. It's either this one or another one. Let's see what happens here.
Andrew, we're here with Epirus Leonidas. Can you talk a little bit about this system, please?
Absolutely. So Leonidas is our flagship ground-based high-power microwave system. At Epirus, we develop high-power microwave systems for counter-electronic effects. First mission application of that technology is going to be counter-drone. And what's great about our system is that it can take out both individual drone targets, or we can then widen our HPM beam to take out swarms of drones. So under contract with the Army for this system, and we really see it as the most effective and efficient HPM system for that counter-drone swarm mission.
And can you describe to me exactly what happens when a swarm of drones comes near it to the area?
Absolutely. So we put up, think of it as a shield of high-power microwave or directed energy. What the system does is it destroys the critical electronics of that drone target. So once we put effects on that target, drop straight to the ground. So it's a step up from other CUAS technologies like jamming, which just cuts off the C2 system, the command and control system of that target. With autonomous drones, though, there's not always a command and control platform. So jamming is then rendered useless. So high power microwave takes it a step further. Again, we destroy the critical electronics aboard that UAS, and quite literally it falls from the sky as soon as Leonidas puts effects on it. As we like to say at Epirus, with Leonidas, if it flies, it dies.
And you're under contract with the Army, and you're here at Sierra Space looking at potential opportunities with the Navy. What specifically are you looking at? What kind of problem are you trying to solve with the Navy?
Absolutely. So great to be back here at Sierra Space. We've had some really great conversations with our counterparts throughout the sea services this week. So yeah, under contract for Leonidas with the Army, but also exploring future maritime applications of our HPM technology. So think terminal defense, port protection, have some Leonidas stationed around a naval base to protect again against both individual aggressor drones, but also swarms of drones. We've also demonstrated the effectiveness of our high power microwave technology on an outboard vessel motor. So talking a lot this week to our counterparts in the Navy, the Marines, and Coast Guard about potential vessel stop capabilities. Again, so it's not just counter UAS. That's the first mission application of our technology, but it's more broadly a counter electronic system. So you can take out a drone, you can take out a swarm of drones, you can take out an outboard vessel motor, and the list goes on. Counter UAS is really just the tip of the iceberg when it comes to our technology. So we're certainly excited about continuing our talks with the sea services for future maritime applications.
What sets this one apart from other systems?
Yeah, a few things. Size is a huge one, right? We've revolutionized what's called the swap factor, size, weight, and consumption of power. Competitive HPM systems are going to be incredibly large, occupy the size of a shipping container. Leonidas is dramatically smaller, can fit in the back of a commercial pickup truck, can be fit in the C-130, can be towed by a commercial grade trailer. So size is going to be a huge differentiator. Also, the software definability of the system is another key differentiator. And what that does, based with our software backbone, we can very precisely control our HPM pulse. So
Leonidas platform, can it be put on a mobile platform?
It can, and that's another huge differentiator of our technology, the modularity and scalability of our systems. We can rapidly scale up or scale down the systems to meet customer requirements. So we've integrated what you see here, our Leonidas high power microwave array with.
Okay, that was enough. I wanted you to see the fact that this antenna is actually frying the electronics. It's frying, basically the drone's electronic circuit boards are being overloaded and overpowered and are probably arcing, if I understand this correctly. So that was something I thought you might enjoy to see, drones falling out of the sky if you don't like drones. Let's see, let me go back. This was actually the talk I wanted to show you. This is the detecting. So let's see if I can get this detecting one. There we go.
With Fusion 360, you can control your data, drive your machines, simulate your.
These people are really clever. This is where it starts.
5 years ago, we introduced Elvira. And the main goal of Elvira was to be the first mover in the market with a real drone radar that really works, that really is able to see drones in the environment and give you an alarm as soon as the drone comes in. When we introduced Elvira, we already knew that the market would request for extra features. First of all, the cone of silence must be very small. You want to know whether a drone flies right above you. And for that, you need a very small cone of silence in order to see all the drones that pass by. The second thing was that 3D information gets more important every day, because you do want to know not only where the drone is, but also how high it flies. And the third thing that we also knew beforehand was the fact that people like to have a thing which is mobile, which you can easily carry, and which is not too big. So size and weight are very important.
At Robin Radar Systems, we've been focusing a lot since the beginning on delivering a good radar, good hardware. From working with a lot of clients, customers, all sorts of end users, really, we really noticed that most of the clients are interested in the information that the radar is providing. So our mission is increase safety and security by delivering actionable information. With this in mind, what we did, we had to expand our R&D team. With this team, with these software people, we are now really invested in focusing on developing interfaces that provide this information, provide this data, the way the customers really want to see it and the way the customers can act on this kind of information.
One big advantage that we had, in the meantime, we're developing a new bird radar called Max. And we learned a lot in that process, and particular new technologies that we had experienced in that project were very useful to quickly be able to make progress in the IRIS project. We think that the best way to make the difference between a drone and a bird is by detecting the small blades that are on drones. And that's not an easy thing. You have to find the micro Doppler profile in a picture. And if you want to find that, you need quite some time to really focus on that particular thing flying in the air. That means that you have to rotate very slowly because you need to see this particular thing a long time. But if you rotate very slowly, you get updates very slowly, which also means that you cannot track the drone anymore. So you might see it, but you don't know where it flies. We found out in practice that you really need an update every second. And if you have an update every second, you don't have time to analyze that picture. So that's why we had to find a solution.
While developing the Iris software, we kept in mind that we wanted to facilitate using Iris and integrating Iris into bigger multi-sensor drone detection systems. So the Iris comes with an API that integrators can use in their command and control interface. And via this API, they can send commands to the radar. They can start and stop, for example, and they receive information about what's going on in and around the radar, status information, tracks, etc., etc. This makes it really easy and simple to put the Iris as one of the sensors in a drone detection system.
De landmacht is gestart met een klein team counter-drones. Want we zien een nieuwe dreiging. En dat is ondergebracht bij het Defensie Grondgebonden Luchtverdedigingscommando van de landmacht. Dat team, het team waar ik leiding aan geef, is bezig met het voorbereiden van een nieuwe capaciteit. Voor het verwerven van counter-UAS-systemen. En daarvoor ook concepten en development te doen en experimenten uit te voeren. En dat doen we op een testcenter. Wat speciaal ook daarvoor is opgericht op de luitenant-generaal Bestkazerne. Daar waar ook het Defensie Grondgebonden Luchtverdedigingscommando is gehuisvest. De drone-dreiging die we op dit moment ervaren, is te onderverdelen in grotere drones en hele kleine drones. De grotere drones die worden gedetecteerd door de systemen zoals we die nu al hebben. Daar kunnen we al iets tegen doen. Dus daar richten wij ons niet op. Wij richten ons juist echt op die hele kleine drones. Dus de nano's, de micro's en de minis. En waarom? Omdat die dus moeilijk te detecteren zijn door de huidige systemen, moeten we zoeken naar nieuwe systemen, nieuwe mogelijkheden. En omdat we praten over snelle drones, die moet je snel kunnen detecteren. Daar kan een radar absoluut een grote rol in hebben als we praten over het verkrijgen van een XYZ-positie. Dat betekent dus 3D, dat we exact weten waar de drone is, zodat andere systemen dat ook weten. En dat geeft een snellere beslissingsbevoegdheid. Want die dreiging die is daar, die is militair en die is civiel. Als ik nou kijk naar civiel, dan praten wij vaak over de vader-zoon actie, die dan gewoon met een drone rondvliegt omdat ze leuke dingen zien. Een vliegtuig, die wil ik van boven filmen. Maar dan komt het vliegveiligheid komt dan in het gedrang. En dat wil je dus niet, dat zo'n groot vliegtuig eventueel neerstort doordat zo'n kleine drone in de aanvliegroute van een vliegveld ligt. Maar ook militair. Als wij op uitzending zijn en de vijand probeert ons te bespieden met camera's of zelfs bommen te gooien of erger, dan hebben wij daar last van. Dus wij moeten ons daarop voorbereiden. Ook als we in ons normale optreden zijn, als we buiten de poort begeven, zullen we onze groepen, onze pelotons, onze brigades ook moeten beschermen tegen die drone-dreiging. Want ook dan willen we onze posities niet vrijgeven.
We decided to make 2 radars instead of 1 radar, which is Iris. But inside, when you open it up, you'll find 2 faces, one looking to that side, or one looking into that side. And those 2 faces work simultaneously. This also means that we can rotate very slow. We rotate 30 rounds a minute, which is quite slow. So we do have time to really focus well. But on the other hand, you get an update, a new picture every second, because we have 2 sides. So the trick is pretty straightforward. It wasn't easy, but we succeeded. And I'm very proud that we now can launch Iris.
Thank you for watching that. That is one of the best engineering video advertisements that I've ever seen. I wish YouTube would splash me with those kinds of ads instead of all the other stuff they send at me. So I can go a little bit back and try and get past this one and see what we want to see. There are drone, I want to state that we had people killed in our military because of a drone attack on a camp, and they had a radar that was not operating 80% of the time. It was always broken. So that detection system really impressed me. That's why I made you suffer through that long of a video, but I thought it was great. And also, you know, you could protect the president of the United States with one of those to make sure that there's no drone activity where they are, that kind of thing. So it's pretty amazing what they did with that spinning radar. We actually had something like that on the bottom of the Triton, which was a two-sided radar. So it's not a new concept, but it sure helps to have two radars at the same time. I don't know, how much time do we have here? It's about 8:27. Let's see. So there are antennas that are used on guns. The AliExpress drone killer was $31. I picked one of those up myself, and it's very useful in a gun if you want to use the 5.8 gigahertz is the smaller trace, and the 2.4 gigahertz is the larger trace. What typically is done in these guns, let's see if I can find the guns. That's the, let's get down to the guns. There they are. There's one of them. Typically, what is done with the guns is they either have a log periodic and a circular polarized antenna. Circular polarization is used for the GPS. So you can jam the GPS and the drone won't know how to go home. You know, it's programmed to go home if it is jammed. And if it's jammed on the 5.8 gigahertz and 2.4 gigahertz on the slug periodic, it can't get the signal to, you know, be commanded, and the video will cease. So it's pretty amazing. I think what I want to do is show you a video of a Ukrainian mission, if I can find it. It should be here. If I can get it started. This one's kind of interesting.
How to open your car door while submerged underwater. A fatal construction flaw in all recent auto.
Now to Ukraine, where heavy fighting continues as Russia tries to...
Okay. Dusk begins a race to hide before dark.
This is really amazing.
This drone unit's first night in a new location.
What?
Twilight. Tiny window when perhaps you can unpack, set up without the Russian drones that are always above, seeing you as clearly. Like so much in this fast-changing war, their task was unimaginable when Moscow invaded. Their target is on the horizon, Russia itself, into which they fly and plant mines on key roads. They wait for dark.
Those lights twinkling over there on the horizon, that's Belgorod, Russia. How close they're operating towards Russian mainland.
Putin's latest offensive towards Kharkiv has made the fight personal for Artyom. His parents live about a 5-minute drive away, and fighting for his literal home is unsettling.
Волнительно, на самом-то деле. Они, полтора года не знали вообще, что в боевой бригаде, что я под Бахмутом воюю. Я рассказывал, что на блокпосты охраняю.
And now, for the first of many times, their only defense is to listen for drones.
Назад. Прямо над нами летит. Орлан.
It passes. Now it is dark. They must hurry. Russian drones have thermal cameras. They hear another.
Тихо.
Battles raging nearby may help them go unnoticed. They resume. Any strike could also ignite the two mines they're fitting. They hear another drone.
That's нормально поработать, давай.
Such an escalation over 2 years into the war to now see Ukrainians flying drones of explosive straight into Russia.
Inside, Sasha watches it cross the border.
Ось що кордон проходить. Ти паспорт взяв з собою? У мене безвіз.
GPS ban. Communication lost.
Remarkably, when Russian jamming kicks in, the drone keeps going.
EKF primary changed :2.
And they're able to pick the signal up again, deeper inside Russia. They spot the target road they will mine, drop both payloads, and head back. A GPS problem means the drone crash lands, but they have a spare. They once, elsewhere, managed 24 sorties in one night. But they have to be spotted only once, and these shells may not pass.
Okay, I hope you like to see that. That was scary. I suppose you're out there and you're hearing a Russian drone over your head, which has infrared cameras. It's amazing what these guys are doing, and that's why our military is, trying to find out what is the best way to counter drones in the field, and why I got involved in this little study here. I'll try and see if there's anything I really, really want you to see. I mean, look at this guy with his antennas on using the first-person view drones. These guys are flying bombs right into people. I mean, they're just running them down with the first-person view drones. Pretty amazing. The drones themselves, I was talking about the antennas. You actually have the Russians putting up the Ukrainians putting up repeaters. And so the little drones, the first-person view drones, get directed by the large drone and can get a direct signal. Instead of being jammed by the Russians, they can get their signal up to the mothership here. So that's pretty clever, and it's obviously the way things have to work. Things are going to do AI now. You're going to have to control 10 drones at a time, which is not really easy if you have if you think about swarms. So the next new progress has to be on sorting out swarms, and the Russians were actually complaining about these things. The Baba is the Ukrainian drone that has the repeater, and let's see if there's anything that. Yeah, this guy here is a Russian. He was really upset. He says this Russian serviceman was apparently a witness to the flock of Ukrainian first-person view drones led by a separate drone, Queen, which descended onto Russian positions and started the bombing. So what happens is you can hang loose with all your first-person view small drones and save their batteries. As I mentioned earlier, batteries are really important. If you are going to drop a bomb, guess what? You only have to go half as far as when you want to take your drone, drop it, and return your drone. So these kamikaze drones can fly pretty far and deliver their payload to all kinds of vehicles out there. Let's see if there's anything else. I did want to show you that I flew out in Hawaii, and I did lose signal. This is where my hotel was over here. And this is Diamond Head, of course. And right as I came in, I started losing signal. And the drone went up and turned around and started going home. And I got a map from my iPhone, and I saw where this drone had actually gone. Here's where I'm flying by hand. And I said, oh, I'm interested over here. This looks interesting. I flew to this point, and the drone said, I can't, I've lost signal. And it started, turned around on its own and raised up to about 90 meters and started heading back home. And I took control of it. The antenna pattern looks like this. This is a near field plot if I'm sitting at my hotel. So it was pointing out this direction. And I actually got a map of Hawaii, and I put a metal plate in here. And it turns out that the drone was being blocked by this building. And this is a plot based on that map of where I am with the drone. And as I raise my altitude from 0 to say 90 meters, the signal strength goes straight up. So basically I was being in the shadow, and by raising up in my height and altitude, I got the signal back without any problem. And I took over and flew back home and told the drone to leave the controller to that I would fly home. And so I did get a bunch of toys. I got a new spectrum analyzer. I have a log periodic. This is an anti-drone antenna, or at least something to pick up drone signals. And there are anti-drone antennas that are circularly polarized for jamming the GPS. And there are drone extenders where you can set these up with your drone, depending on which one, and you can fly 25 miles. So you can pay $2,800 for those if you want them. And then there's, of course, these other jammers. So I think that's pretty much what I wanted to cover. Everybody, I think that you may sense how I feel so comfortable with flying a drone and enjoy flying the drones. By the way, this is a helical antenna I wanted to point out, because this is the Ukrainian drone, and I believe this is so that it can talk up to the mothership. No, I haven't seen these before, but with the 5.8 gigahertz, you could talk to your mothership, your controlling drone, and then of course these are plastic explosives, so it's kind of scary, and I wouldn't want to be that guy. These are the this is just a cheap one if you want to buy 12 turn 5.8 gigahertz antenna. So I think I've exposed you to at least what I've seen is in terms of hardware that's out there. So I'm going to open up the floor now.
Somebody in the back there. Okay, we have a question for you, Keith.
Sure.
Adrian.
Thank you, Keith. Very interesting. I have two questions. First of all is, you worked on this, what is it, Global Hawk? So I think it was 2020 or 2018, 19. I think, was it North Korean or Iranians? They say they forced it to land, but maybe they shot it.
No, they shot it down.
Oh, I see.
Yeah.
Okay, good. And that was my question. I mean, if you want to disrupt the GPS, they use probably the military GPS. It is not easily jammed, correct?
Well, yeah. I'll repeat. They have, for the jamming guns, they jam 2.4, 5.8 gigahertz. Those are the video and the controlling frequencies. Correct. And then the GPSs are
0.2
GLONASS and L1 and L2. Yeah.
So, okay. So if they jam probably the GPS, the drone is still functional.
The drone can't go home because it uses the GPS to navigate.
So what does it do? It lands.
It falls. That's why I showed that video of the Ukrainian drone pilot. They went ahead, they flew out, they were jammed, but they got through the jamming to their target. As they turned around, they were still jammed, and they got jammed so much that it fell down.
I see. Okay.
Yeah.
So this is one thing. And I know the newer drones, they have the geofencing. So certain areas are geofenced. Theoretically, can somebody disrupt the geofencing and then, let's say, I don't know, fly into Moffett or somewhere? All these Chinese drones, do they honor the geofencing data?
I'm not in a position to say, but I will say that that segues me into sort of the end of this talk. The Russians don't give it, I can't use a four-letter word here, but they don't care about international law. And so this is a comment I wanted to read to you. 2 retired special ops personnel singled out Russian and in their publication, this is about why the U.S. jamming tech is so far behind Russia. They said that one reason the Kremlin's technology is significantly better is because it ignored international laws designed to stop jamming of civilian telecommunications. So if you remember, I gave, I don't know if you were in the this talk, but this talk here is still online, and you can go to it at this link about the Russian woodpecker, which was jamming everybody in the ham radio band. And one comment I would make is that it's received 5.4 thousand views, which is, can you imagine an antenna talk getting that many views?
Impressive.
I'm pretty proud of it. For a farm boy from Ohio, I'm pretty proud of that. So, and I had a lot of help from Steve Stearns and Scott Burnside on that. Do you know what the Russian woodpecker is? Have you seen it?
Yeah, of course. The over the horizon radar. Yes.
Right. Okay. So that talk is still available if you want to watch it on YouTube. All you have to do is search for RSGB, Radio Society Great Britain, and the word woodpecker, and look for this tonight at 8, and you can go back there.
So
there you go.
Yeah, just my last question.
Sure.
So if I get one of these tiny essays and then put it under maybe a Yagi on top of my roof, can I detect the drones, or is it frequency hopping? Is probably kind of, it looks just like random noise, or is this something the commercial drones, can I detect them?
Yeah, let me see here. Let's go back to this guy here. Let's go here. This is the DJI Mini 2 hovering and broadcasting at 5.8 gigahertz. So he's talking to his controller at 5.8 gigahertz. Controller's over here, and I'm monitoring the signal level with a log periodic antenna that's hooked up to a tiny SA spectrum analyzer. Marker 1. You saw a packet there. Now over here, you'll see packets.
I see.
Around minus 50. So this is like a mountaintop here, flat mountaintop. dBm. 5.8 something gigs.
So it is basically detectable.
Yeah, and this does have a LNA, excuse me, an amplifier inside of it. So I did turn that on.
I see.
Get a little more signal.
So if I at night see something on my spectrum analyzer, I bring the bird shots out. Okay, thank you very much. Very interesting. Thank you.
Yeah. I'm glad you asked that question, because I did want to show at least one of these. I can show you another one if you got a second, just to show you that the signal strength. This is the DJI Mini 2 hovering. Well, here we go. So now I'm using a spiral right there. So let's go see what the spectrum analyzer is telling us. So I'm looking at what kind of antenna can you attach to a rifle for the military, and which fits better and which would do the job. And a circular polarization is good. It's beneficial. It's only got 3 dBi gain though, compared to say a Yagi-Uda. So you can see the spectrum again. The little one is a marker, and the frequency is on the top left. And it's hovering around minus 50 dBm. This is with a LNA turned on. Just bear with me, one more. This is the last antenna. So I'm really testing the antenna, not the drone. DJI Mini 2, currently operating in the 5.8 gigahertz band. And I'm looking at it with a Yagi-Uda antenna over here. I really like the glass vase that my wife has here. Held this really nicely. Using the top 5.8 gigahertz. So you can see the levels are about the same for all three of those antennas. Isn't that cool?
Okay, do we have any more questions? Somebody?
The lady here had one.
A question. All right.
Hello. I had a couple of questions. Well, one, from the perspective of someone who's making a drone, do you know any good way to prevent the drone from being jammed?
That's $1 million question. As you saw, I had that 4 antenna drone that's not been made before, but there are ways to steer nulls towards jamming signals. So the answer is yes, you can do it. It's going to be more expensive and it's going to take some processing. The higher the gain that you have with lower side lobes, in other words, if you have low side lobes not in the direction of your transmission, then the jamming signals have to get into your main beam. So if the jammer is not in your main beam, then you're in good shape. So you could actually have fairly directed antennas either looking forward or aft or left or right, and use those to have a strong signal to your controller.
Okay. Second question was like, I wonder how they do that in like missiles, because I've never heard of a missile just, losing its way.
That's you haven't heard of that before? I'm not sure I can answer that question, to tell you the truth. I do know that they put spiral antennas in the front of these missiles, and you do raise a good point in that if you want to invest in a business right now, the most expanding business is a steerable munition. So the Russians have these crazy looking UAVs, and they're basically bombs that you just fly around and they hover and they loiter, and then when they feel like coming down, they come down. So that's where a lot of new business is, unfortunately for mankind.
Thank you.
I will say one thing. I am absolutely appalled that there was no drone protecting, say, Donald Trump. I couldn't believe there was not a drone in the air. I had just seen fireworks in Oceanside here, and the police had a drone in the air watching the crowd, and I was waving to the drone, and I felt safe, and I smiled at it. That's the way you should handle it. When you see a drone, just wave and smile. Okay.
I heard the person like flew a drone there just to like survey the area, like the shooter.
Keith, I heard the FBI could actually reproduce the route of the drone. I don't know how they did it, but something was probably monitoring the airspace.
Wow. Well, perhaps the cell phone towers. They're at 2.4. But yeah, you're right. I think that there's a lot to be said about the positives, and that's why I did show that detection spinning radar. I was really impressed with that, and the fact that they could discern from a bird or a drone by the Doppler shift on the propellers. Now, I did have one. I wondered, what if the propeller is not made of metal? So maybe that's something they have 50-50 chance on. But I really appreciate you guys showing up. As you can see, I like doing drones. I mean, it's crazy how much fun you can have with them. And let's see if I can move this real quick.
Question.
Yeah, go ahead. Yes.
Can I go ahead?
Go ahead.
Yeah. So as a consumer, and I realize, I was going to say, first of all, I certainly appreciate all the research and activities you're doing here with these presentations. Very interesting. I was wondering, consumer-wise, acquisition of a system, with some capabilities, what's the price range, would you say, for consumers?
Yeah, let me tell you how I did it, and I think this is a very smart way to go. Go on, if you do have Facebook, there's Facebook Marketplace, and you can buy a used drone from somebody because they always want to trade up. So I have a DJI Mini 2. Well, there's also DJI Mini 3 and a DJI Mini 4. And so a person who wants to, buy the next version of drone will sell his old drone. So I bought mine for $305. And I bought, before that, very inexpensive drones, say $80 or $60 to begin with, but they didn't have all the features of that expensive DJI drone. But what I wanted to do was buy a cheap drone in case I crashed it, because I didn't know if I could fly it. And in fact, when you have a cheap drone without a GPS, the wind will blow it into the trees really easy, and it'll take off really easy. So you got to learn how to fly. And I was able to do it, but I hit a few trees, and I bounced a little bit on the driveway. Go and get yourself. Oh, this is the best part. With the used drone, I bought it, I flew, I trained myself, and then I sold the drone for the same price I bought it for. I did that 3 times. And then I said, okay, I'm going for a DJI.
So $300 is a range?
That's a used price. But you can get a fairly decent drone between 300 and 500. Yes, DJI. The thing about them is they're so safe. It says you're out of battery, I'm coming home. It says the wind is too strong, lower your altitude. What's the other? Yeah, the other warnings are lost signal, and I'm flying home. So they're really very, very amazingly smart and very beautiful. I mean, the 4K, I play it on my 55-inch TV at home, and I'm just like astounded at how much detail you can see.
All righty, thank you.
Okay. Shall I release control?
Okay. Anybody on the Zoom room that would like to ask Keith a question before we close on this? Okay, I'm not hearing anything. So, okay, Keith, I think we're done.
Good. So I'll stop sharing, and you can